As we go along, our balancing starts to get a little bit more complicated as we go, and that chart becomes necessary. Remember, for Unit 3, you have to show the reactants, elements, products chart to get credit. After Unit 3, you won't have to show the chart anymore if you can do it visually. But this gets the system in your brain how it works, and sometimes I still have to go back and do this chart on some really complicated balances. Okay, so we have PB. I see the NO2 nitrite is on both the left and the right sides. So if I see a poly, how do I know it's a poly? I see the parentheses. Okay. Sometimes it's there without the parentheses, but that's a big clue. Whenever you see parentheses, it's a poly. And if it's on both the left and right, then you can keep it together most times. Magnesium and chlorine. Okay. You're keeping these as individual atoms. So no Cl2, just Cl. And then we count on the reactant side, which is what's on the left, because reactants are your ingredients to make something, to make a product. So your products are on the right. That arrow is called the yield because it's what's creating or yielding something. Okay, PB, there's nothing there, but I know that's implied. So there's one PB or one lead. The parentheses are around the nitrite, so I know there's 3 nitrites, 1 magnesium, 2 chlorines. On the right side, again, 1 lead, this time 3 chlorines, 1 magnesium, and 2 nitrites. Remember, the NO2, that's all protected in the bubble. So you could count it all out even individually and have nitrogen and oxygen on separate lines. There's nothing wrong with that. But if you see everything's protected in a bubble on both sides, this speeds things up a little bit because sometimes you can see the patterns faster. So what I look here, I see my lead and my magnesium are happy exactly how they are, so I'm not going to start with them. And I can start with nitrite or chlorine, but I noticed something. I have an odd and an even and an even and an odd. That means I need the odd-even rule, which is to use the least common multiple. 3 times 2 is 6. So my goal for this line is 6. 2 times 3 is 6. So 6 is my goal for that line. So this nitrite has 3, and I need to get him to have 6. 3 times 2 is 6. I can't change here. I can't change inside the bubble. I can only change coefficients at this point. So 2 times 3 is 6. That gives me 6 nitrates. So I'm going to fix that to 6. But that also changed my lead, because remember that coefficient gets distributed. So now I have 2 leads and 6 nitrates on the left. Chlorine had a 3-2 rule as well. So instead of 2, I need to get something here to make 6. What times 2 is 6? 3 times 2 is 6. And then update my chart and make sure you update for magnesium and chlorine. 3 times 1 for magnesium is 3. 3 times 2 for chlorine is 6. So now I go to my right side. I'm following the rules. I'm getting everything on these rows as a 6. Okay. Chlorine here, I see is a 3. Okay. And what do I need to do? I need to get 6. Something times 3 is 6. 2 times 3 is 6. So now I'm changing the right side to the right of the arrow. And it didn't just affect my chlorine, it also affected my lead. 2 times 1 is the new lead number. And look at that. It kind of magically fitted itself in when I fixed the chlorines. You'll see that happens quite a few times. If it doesn't, and you get stuck in a cycle, start over again, because you might have accidentally written down a wrong number that messed you up. Magnesium. Oh, here we go. Nitrite. I have to get to a 6. There's a 2 here. 3 times 2 gives me 6 nitrites. And it also changes my magnesium. 3 times 1 is 3. And then I go back and check for conservation of mass. Conservation of mass. Matter cannot be created nor destroyed. Atoms cannot magically be on one side and not on the other. They have to be in accounting on both sides. Leads, both sides are 2. Nitrate, both sides are 6. Magnesium, both sides are 3. Chlorine, both sides are 6. Yay, confetti. Think about this as just a satisfying, yes, I got it. Don't skip this step because that gives you a little bit of a breather to go, okay, I'm on the right track. I know what it is. And then if you were plugging this in on a computer, you'd be putting in the 2, the 3, the 2, and the 3 for your coefficients.